Hello, everybody, and welcome to this week's lesson. We are on Unit 12, Two-Dimensional Geometry. This week we're talking about triangles, rectangles, and circles, our basic shapes. So for our lesson today, you're going to want pencil and paper. You're going to want your welcome packet with you because we're going to be using your formula sheet, and you can find that formula sheet in your welcome packet. And you're also going to want to have a calculator next to you. Using your phone will be fine. And we're going to get started with this warm-up problem. This warm-up problem is from our lesson from Unit 11. So if you worked on Unit 11, which is about writing, solving, and graphing linear inequalities, then this problem should look familiar to you. So the directions say solve, then graph the solution using a number line. So first thing we need to do is we need to solve this inequality. This inequality says negative 4m plus 2 is greater than or equal to negative 10. So when we say solve this inequality, we mean solve it for the values of m that will make this statement true. So I'm just going to go ahead and follow the process that we practiced when solving equations and with solving linear inequalities. Our goal is to eventually isolate our variable, isolate the m on one side of the inequality sign, which means we need to cancel out this plus 2. We also need to cancel out the multiplication by negative 4. And since we are canceling things out, we're kind of working backwards here. That means we want to work backwards through the order of operations. We want to start by canceling out any addition or subtraction first before we cancel out multiplication or division. So we start by canceling out this plus 2. We cancel it out by doing the opposite. We minus 2. We do that from both sides. And so on the left side now, we're left with negative 4m is greater than or equal to. And then over on the right side, we have negative 10 minus 2. So negative 10 minus 2 will give us negative 12. So we're getting closer to our goal of getting that m by itself. We have one more step, which is to cancel out that multiplication with negative 4. So to cancel out the multiplication, I'm going to divide. That will cancel out that multiplication with negative 4. We got to do the same thing to both sides. So over on the left side, all we have remaining is m. Over on the right side, negative 12 divided by negative 4 gives us 3. And then we have one more thing that we need to remember. We need to remember that for inequalities, when we multiply or divide both sides by a negative number, like we did here, that is going to make the inequality sign flip. So greater than or equal to will become less than or equal to. And now we've achieved our goal. The m is by itself on one side of the inequality sign, and this is our solution. So m can be any number that is less than or equal to 3. This is our solution. And now let's take a little bit extra time here to check our answer and make sure it makes sense. So we're going to pick any number that fits this description. We're going to pick any number that is less than or equal to 3. So I'm going to go ahead and I'm going to pick 0 because that's less than 3. So that will work. And I'm going to return to my original inequality, and I'm going to replace m with the value 0. And so when we double check our work here, we're going to do the calculations and we would expect to come up with an answer that makes sense, hopefully. So I'm going to go ahead, I'm just going to do the calculations here. We got negative 4 times 0, which gives us 0. And then we have 0 plus 2, which is 2. And 2 is greater than or equal to negative 10. That's a true statement. And so that tells us that our solution is probably correct. All right, so let's go ahead and take a look at our learning goals for this lesson. By the end of this week, you will be able to identify basic plane figures. So we're going to work on identifying our basic shapes. We're going to compute area and perimeter of triangles and rectangles, compute side lengths of triangles and rectangles when given area or perimeter. We're going to compute area and circumference of circles, compute radius or diameter when given area or circumference. And finally, we're going to use the GED math formula sheet to help us solve problems. So like I said, you want to make sure you have your welcome packet out next to you with that formula sheet open. If you don't have your welcome packet with you, if you lost it, then you can go ahead and this is available online. If you Google GED math formula sheet, you should be able to find the PDF file for the formula sheet. It should be one of the first results when you search for it. All right, so let's go ahead and let's get some practice with identifying plane figures. First, we need to know, what does this phrase mean? What is a plane figure? Well, when we say the word figures, it really just means the same thing as shapes. So figures and shapes, same thing. And then plane, so in math, the word plane means a flat surface. So when we say plane figures, we really are talking about flat shapes. We could say flat shapes, or we could say 2D or two-dimensional shapes. That's why this unit is called 2D geometry, because we're talking about two-dimensional or flat shapes. That's different from 3D shapes. So 3D shapes are things like cones, spheres, pyramids, boxes, those three-dimensional shapes that kind of pop out at you. That's not what we're talking about this week. This week, we're just talking about 2D flat shapes. All right, so our first shape up at the top here is a circle. Circles are a little bit different from just one circle, not many circles. The circles are a little bit different from the other shapes we're going to be working with, because circles don't have any sides, right? Circles just have that curved edge to them. All right, this orange shape over here, it has 3 sides and 3 angles. 3 sides and 3 angles, right? We want to remember that an angle is the space where 2 lines meet each other. An angle is kind of like a corner. So a shape with 3 sides and 3 angles, that's a triangle. A triangle. So a triangle has 3 sides and 3 angles. Another useful fact that's good to remember about triangles that can help you solve some problems you might encounter on the GED test is that in any triangle, absolutely any triangle that you will encounter on the GED test, the sum of the angles, so if you add up the measurements of all 3 angles, is always 180 degrees. So no matter what the triangle looks like, no matter the lengths of the 3 different sides, the 3 angles will always add up to be 180 degrees. And you can use that fact sometimes to help you solve for missing angle measurements. That might be useful to you in certain situations. Okay, and then the rest of these shapes on this page here, they all have something in common. The rest of these shapes are all 4-sided shapes. And we have a name for 4-sided shapes. Those are called quadrilaterals, which is Latin for 4 sides. So quadrilaterals. Quadrilaterals are 4-sided shapes. And we have another fun fact about quadrilaterals, and that is with these 4-sided shapes, there are 4 angles. The sum of the angles is always 360 degrees. So no matter what 4-sided shape you're looking at, No matter the different side lengths, the different angle sizes, the 4 angles will always add up to be 360 degrees. And again, you can use that fact to help you figure out missing angle measurements. All right, so let's talk about this first quadrilateral here, this purple one. This shape is called a trapezoid, which I always think is a very fun word. Anything that ends in zoid is pretty fun. So this is a trapezoid. You might also sometimes hear it called a trapezium. That's another name for this shape. A little bit less common, I think. People don't use that word quite as much, but you might encounter it. So sometimes it's called a trapezium, which also sounds pretty fun. And what makes something a trapezoid? When you look at a shape, how can you tell it's a trapezoid? Well, it'll have 4 sides. And with those 4 sides, you will have exactly 1 pair of parallel sides. And parallel, when lines are parallel to each other, that means they are running in exactly the same direction. So with this trapezoid, if you look at the top and the bottom, those 2 sides are parallel to each other. They are pointing in exactly the same direction. They will never meet. If you extended those lines out, they will never intersect each other. They will just keep going forever and ever in the same direction. That's different from the right and left sides of this trapezoid, which are pointing in different directions. If you were to continue those lines upwards, they would eventually cross each other. All right, and then let's take a look at this green shape here. This green shape is called a parallelogram. Parallelogram. A parallelogram is a quadrilateral, it's a 4-sided shape that has 2 pairs of parallel sides. So this parallelogram, the top and the bottom are parallel to each other. The right and the left side are parallel to each other. You might also notice that with this parallelogram, the right and the left side are equal, right? They're the same length. So I can use these matching tick marks to show that the right and left side are equal to each other. And the top and the bottom are also the same length. So I'll put 2 tick marks there to show that those 2 sides match up to each other. And then it's also the case that the opposite angles are equal to each other in a parallelogram. So this angle, whatever the measurement is, we don't know exactly what it is, but whatever it is, this angle will be the same as this angle here. And then this smaller angle, I'll put 2 tick marks in that, will be equal to this smaller angle opposite it. All right, so that's a parallelogram, 2 pairs of parallel sides. And then next with this light blue shape, we have a rectangle, which I'm sure you are familiar with. Rectangles are all over the place. A rectangle is a quadrilateral. It is a parallelogram. It meets the definition for a parallelogram where it's got these 2 pairs of parallel sides. So the top and the bottom are parallel and equal length. The right and the left are parallel and of equal length. And then the extra thing that makes something a rectangle is that it has 4 equal angles, and those 4 equal angles are right angles. So it has 4 right angles. You might have heard that term before, a right angle. A right angle is an angle that is equal to 90 degrees. So it has a size or a measurement of 90 degrees. And we can use this little square symbol here to show that these are right angles. So a rectangle has 4 equal angles. Each of the angles is 90 degrees. And so with a rectangle, it's easy to kind of double check this fact that we talked about here for quadrilaterals. If you have 4 angles that are each 90 degrees, If you add those all together, 90 plus 90 plus 90 plus 90, you will get 360 degrees. Okay, and next we're actually going to jump over to this last green shape here. We're going to do this one next. So this one is a rhombus. A rhombus is also a special type of parallelogram. You can see it's got those two pairs of parallel sides. And whereas a rectangle has 4 equal angles, what's special about a rhombus is that it has 4 equal sides. So if you look at this rhombus, you can see the angles are different. The angles don't all match each other, but the sides are all the same. So I'm going to put 1 tick mark in each side to show that they are all the same. All right, and then finally we have, as our last shape here, we have a square, another very common shape that I'm sure you're familiar with. And a square kind of takes the special characteristics of a rectangle and a rhombus and combines them. So the thing that makes a square is that it has, it's a quadrilateral, it's a parallelogram, and it has 4 equal sides and 4 equal angles, so 4 right angles. So 4 equal sides, and it has 4 right angles. And I'll show that with these little tick marks here, the 4 equal sides. And I can put those little symbols in the corners to show that these are right angles. Okay. So those are our basic plane figures. You will find each of these appears on your formula sheet, your GED math formula sheet, except for the rhombus. The rhombus doesn't show up there, basically because anything you would need to do with the rhombus, you can do that with the formulas for a parallelogram. All right, so now let's talk about different measurements that we might find useful when working with these shapes. So the most common measurements that you'll be dealing with when you are measuring shapes are perimeter and area. These are very important concepts for the GED test. So these are definitely vocabulary words that you want to remember, and you want to remember the meaning of them. So perimeter, the perimeter of a shape is the distance or the length around the edge or the outside of the shape. And so it's measured in units of distance like inches or feet or miles or centimeters, yards, etc. So for example, let's take a rectangle. Let's say this rectangle is 2 inches by 3 inches. So the perimeter of this rectangle would be all of the sides added together. When I look at this shape, I see that only 2 of the sides are labeled, so I can go ahead and assume that this opposite side here is also 3 inches, and this opposite side here is 2 inches. So the perimeter would be adding up all of the sides. So 3 inches plus 3 inches plus 2 inches plus 2 inches will give us 6 plus 4, which is 10 inches. So the perimeter of this rectangle going all the way around the outside is 10 inches. So in general, when you're asked to determine the perimeter of a shape, you just want to remember that that means adding up all of the sides. And you want to make sure you don't skip a side by accident, because then your answer will be too short. All right, and next we have area, another very common measurement that we might take for a shape. An area is a measurement of the amount of space inside of a shape, inside of a flat shape. And this is always measured in square units of distance. So you might be familiar with this from if you've ever been apartment hunting or house hunting. Usually one of the pieces of information that you will get about that apartment or house is the square footage. So if you are renting an apartment and they tell you that it's 750 square feet, That is the area of the floor plan of your apartment or house. So like if you were looking down from the ceiling of your apartment, let's say it's shaped like this, something like that. If you were looking down like a bird, looking down at your apartment, the 750 square feet is the amount of space that the floor covers. If you've ever needed to like retile or recarpet a floor, you might have also had to measure the square footage of the space that you were dealing with. So let's take this same rectangle, this 2-inch by 3-inch rectangle. And typically when we are calculating area, we're going to want to refer to the formula, the specific formula for that shape. So if you look on your formula sheet, you'll see there's a section about area, and it says area of a rectangle. It says A equals LW. So that means area of a rectangle is equal to the length times the width. So you basically take the two dimensions of the rectangle and you multiply them together. Calculating the area usually involves multiplication, right? Whereas perimeter, we can just add up all the sides. With area, we're usually multiplying. So for this particular rectangle, we're going to do 3 inches times 2 inches. And so I did 3 times 2 because I would probably think of 3 as the length of this rectangle and 2 as the width. But it actually doesn't matter which side you label as the length or the width. You'll notice that 3 times 2 is the same as 2 times 3. So it doesn't really matter which one you say is which, as long as you're taking those two dimensions and multiplying them together. So 3 inches times 2 inches will give me 6 square inches. And a nice short way of writing square inches, instead of writing it all out, we can just do inches with a little squared. And really where that comes from is we're doing, right, 3 times 2 is 6. And then inches times inches gives us inches squared. So that's why we're getting this result of square units when we talk about area. You can also kind of get a visual understanding of what these square units mean if we look at our shape here. So we know that the width is 2 inches. I'm going to split this side up into 2 equal parts, 2 equal inches. And then the length is 3 inches. So I'm going to split this length up into 3 equal parts. And so if I had drawn this rectangle to scale, I would have gotten 6 individual squares, right? 6 square inches, 6 little squares that are each an inch on every side. And if we count them up here, we can see that there are 1, 2, 3, 4, 5, 6 square inches on the inside of this rectangle. All right, so let's get some practice with calculating perimeter. So let's start with this first shape here, start with this trapezoid. So we want to remember that calculating perimeter means adding up all of the sides. So with this trapezoid, I look at it and I see I've got 3 sides labeled. One of them is not labeled. I'm going to go ahead and I'm going to assume that this side is also 5 feet because it's across from a side that's 5 feet and it looks the same. So I can make that assumption that these 2 sides are equal to each other. And from there, I just add up all 4 sides. So I'll do 5 feet plus 5 feet plus 4 feet plus 6 feet. All together gives me a perimeter of 20 feet. All right, now on to this rectangle. I'm going to fill in my missing sides here. So 2 kilometers and 5 kilometers. A kilometer is a measurement that's a little bit less than a mile, in case you're not as familiar with that unit of measurement. So a little bit less than a mile. And I'm going to go ahead and add up all four sides. Since we're adding here, it doesn't actually matter what order you add up the sides. So I'm doing 5 plus 5 plus 2 plus 2. But you could do 2 plus 5 plus 2 plus 5. You could do 2 plus 2 plus 5 plus 5. Just you do you. Whatever order you want to do it in will work. So 5 plus 5 not equals, plus sign there, plus 2 plus 2. It will give us a total perimeter of 14 kilometers. Now, if you look on your formula sheet, you'll see that there is actually a section for perimeter. For the most part, you don't really need to worry about those different formulas. You're definitely welcome to use them if you'd like to. But those formulas that you see are mostly just little shortcuts for doing this addition. So the formula for perimeter of a rectangle is 2 times the length plus 2 times the width. And you can see here where that comes from, right? We're adding up 2 5s, 2 of the lengths, and we're adding up 2 2s, 2 of the widths. So it's just kind of a different way of organizing those numbers. You'll get the same answer either way. So you can use the formula or not use the formula. It's up to you. All right, and then for our triangle here, you can see each of the sides is the same. This is an equilateral triangle, meaning it's got 3 equal sides. And so I'm just going to go ahead and add up those 3 sides, 9.5 plus 9.5 plus 9.5. And since they're all actually the same, I could go ahead and do 3 times 9.5 centimeters. And that should give me an answer of 28.5 centimeters. All right, so now we're going to kind of flip things around, work backwards, because with these problems here, we have a missing side, but we are told the perimeter. So it's no longer our job to calculate the perimeter. It's our job to use the perimeter to help us figure out what this missing side is. So let's start with the rectangle. I look at this rectangle, I see it's 10 inches in length. I'm going to fill in this missing side here. And then the width is unknown. So we got W over on the right side. I'm going to fill in a W over on the left side because we're not sure of what the width is yet. But we do know the perimeter is 30. So what I would do is I would go ahead and start thinking about, well, what goes into that perimeter? What do I have to do to get to that perimeter? And what I would do is I would be adding up all 4 sides. Now those 10s, I can go ahead and add those together. That gives me 20. And a W and a W, well, that's 2 times W. So now I have an equation that I can solve for W. I'm going to subtract that 20 away. And so I have 2W's equals 10, right? So if you kind of ignore the 10 inches and the 10 inches, then what you have remaining to work with is 10 inches. And that 10 inches needs to be split evenly amongst those 2 sides. And so we're left with W equals 5 inches. Now you should go back and double check your work here, right? If you're saying W is 5 inches, then when you add up all 4 sides, you should get that total perimeter of 30 inches. And that will be the case here. If we add up these 4 numbers, we will get 30 inches. So if you're ever doing a problem like this and you're not sure if you did it correctly, well, you can always double check it by going back and adding up the sides, see if you get the perimeter that you're supposed to get. So W is 5 inches. All right, and let's look at this triangle here. So we know 2 of the sides, 1 of the sides is missing, and we know the perimeter. We want to solve for the missing side. Well, the 3 sides need to add up to be 21 yards. You could go ahead and add up the 2 sides you know, subtract it away from 21, and that'll give you the missing amount. So I'm going to do that here. 12 plus 4.5 gives me 16.5 yards. And then 21 minus 16.5. I'll go ahead and borrow here. Fill in that missing space. It'll become 10. So 10 minus 5 is 5. 10 minus 6 is 4. So we're left with 4.5. So this missing side equals 4.5 or 4.5 yards. 4.5 yards. I think this question is a good illustration of something you want to be careful about when you're working on geometry problems. When you're given a picture to look at, you don't always want to assume that the picture is to scale. So when you look at this picture, you see. All right, so let's move on to our next skill here. All right, so our next skill we're going to talk about is calculating area. And like I said earlier, when you are calculating area, most of the time you're going to be wanting to make sure you use the correct formula for the shape you're looking at. So all of the work we've done already in previous units with equations is going to be a lot of help when we work with formulas, because formulas are just equations. So everything you know about equations you can use to help you work with your formulas. And we want to keep in mind that a mathematical formula is just like a recipe or a set of instructions for accomplishing a task that's written in our special mathematical shorthand that we use. And these formulas can be manipulated to help you solve different problems. So let's return to the example of the area of a rectangle. If you look at your formula sheet, you see that the area of a rectangle is equal to the length times the width. You see this formula that looks like this: A equals L times W. A equals LW, right? So if you don't know anything about geometry, you haven't worked on this stuff before, if you look at this formula, you might be like, I have no idea what these letters mean, right? But with a little bit of practice, right, watching this lesson, you start learning that shorthand, you start learning this kind of special code that we use. So you look at area, you look at A, you know that means area, L means length, and W means width. And this formula can be manipulated or changed around to help us solve different problems. So if we want to calculate area, then we would do the length times the width. But let's say we have a problem where we know the area, we know the width, and we want to figure out the length. Well, we could just move things around a little bit here and do the area divided by the width, right? And that would tell us the length. Same thing for the width. If we know the area and we know the length, the width would be the area divided by the length. So this one formula that we're given, we can use that to help us solve a few different types of problems. All right, so let's get some practice calculating area here. We're going to start with this rectangle down at the bottom, since we've already kind of gotten into the rectangles a little bit. So I see a rectangle. I know that I want to calculate the area, so I look to my formula sheet. And I see the area of a rectangle. The formula is right there. A equals LW. So for this rectangle, that would be 5 kilometers times 2 kilometers, which is 10 square kilometers. And that is my area. All right, now let's move on to this square. So when you look at the formula sheet, you'll see that you do have a formula for the area of a square. A square is really just a special type of rectangle. So you could think of a square as being length times the width for the area. The reason it gets its own special formula is just that because all of the sides are the same, on a square, the length and the width are the same number. And so instead of saying length times width, what they're saying is, let's do the side times the side, which is just the side squared. So this is a slightly different way of saying length times width. So for this square, the side is 6 yards. And so I'm going to do 6 yards squared, which means 6 yards times 6 yards. And that will give me 36 square yards. And that's my area. All right, now let's move on to this triangle here. So I go to my formula sheet and I see the area of a triangle. It's this formula. So A equals 1/2 base times height. So for any shape, if you're talking about the base and the height, you can usually think of the base as like the bottom, and then the height is a straight line coming up from the base at a right angle. So the height is always coming up from the base at a right angle. So for this triangle, the base would be 4 feet, and the height would be 3 feet, because we can see that that 3 feet is coming up from 4 feet at a right angle. So that measurement of 5 feet along the third side, we don't even need to use that. It's not important for calculating the area. So now this is just all multiplication. We could say 4 feet times 3 feet is 12 square feet. And then 1/2 of that gives us 6 square feet. Or you could say 1/2 of 4 feet is 2 feet times 3 feet. 2 feet times 3 feet will also give you 6 square feet. So because that's just 2 sets of multiplication there, you can do it in whatever order feels comfortable to you. All right, and let's move on to this fourth shape here, this triangle. The area of a triangle is 1/2 base times height. So that would be 1/2 times 14 inches times 5 inches. 1/2 of 14 is 7. So 7 inches times 5 inches gives me 35 square inches. And that's the area of that triangle. So you might notice that length and width seems pretty similar to base and height. And that is true. So this formula for a rectangle, we say length times width, but we could just as easily call that base times height of the rectangle. And so a triangle is really just 1/2 of a rectangle. It's 1/2 the base times the height. If I take this triangle and I kind of fill in the other 1/2 here, you'll see I've made a rectangle, and the blue triangle is just like 1/2 of the rectangle. So those two formulas are actually really closely related to each other. All right, and now we're going to kind of flip things around. We are going to solve for a missing length when we know the area. So let's start with this triangle. So we know the base is 12 feet and the height is missing. We know the area is 30. So I see that this is a problem involving area of a triangle. First thing I'm going to do, I'm just going to go ahead and write down my formula. And now I'm going to start filling in the information I know. So the area is 30. I'm going to replace A with 30. And the base is 12. So I'm going to replace B with 12. And that H is unknown. So now this is just an equation that we need to solve. We can go ahead and figure out 1/2 of 12. So 1/2 of 12 is 6. So now I have this equation where 30 is equal to 6 times H. Now you might know off the top of your head that H has to be 5, right? 6 times 5 gives us 30. But if you're not sure, then you would use division to figure it out. 30 divided by 6. So 30 divided by 6 will give us an answer of 5. H is 5 feet. So in any problem involving a shape, I say when in doubt, start with the formula. right? Whenever, if you see a problem involving some kind of shape, get your formula sheet out and take a look at it. All right, so next we've got this square here. We've got an unknown side length and the area is 25 square inches. So I'm going to start with formula for area of a square. A equals side length squared. Fill in my information. Okay, so we are looking for a number squared that gives us 25. Well, that's going to be 5, right? 5 times 5, or 5 squared, is equal to 25. If you weren't sure, then what you would want to do is take the square root. If s squared equals 25, then s will equal the square root of 25, which is 5. So s is equal to 5 inches. Then of course you can go in and double check that 5 inches gives you your 25 square inches, right? So 5 inches times 5 inches does indeed give you 25 square inches. All right. So we've talked about triangles, rectangles, squares so far. Now we're going to talk about circles. And as I said at the beginning, circles are kind of special. They kind of work in their own special way because they don't have sides. So we're going to talk about some important vocabulary to get us started with circles here. So one measurement that we can take of a circle is the radius. The radius is a line going from the center to the edge of the circle. So it's kind of halfway across the circle. That's the radius. And then we could also talk about the diameter of a circle. The diameter is the measurement going all the way across the circle through the middle. So the diameter is actually twice as long as the radius, right? The radius goes halfway across, the diameter goes all the way across. Usually radius is abbreviated as the letter R and diameter is abbreviated as the letter D. So let's say we have a circle and the radius of my circle is 3 inches. What would the diameter of that circle be? The diameter would be 6 inches. Let's say I had a circle and I know that the diameter, say the diameter is 8 centimeters. What would the radius be? The radius would be 4 centimeters. Okay. Next word we want to talk about is circumference. So circumference is just the name for the perimeter of a circle because circles are kind of special. They get their own special name for perimeter. So circumference is the distance all the way around the outside of the circle. And you'll notice here, if you look at your formula sheet, that both of the formulas for circles that we're looking at, so formula for area and formula for circumference, both of them use this symbol. So this is the Greek letter pi. And when we spell it out using English letters, we usually spell it Pi. This is a Greek letter, and it represents a special number. It represents the special number that is the circumference of a circle divided by the diameter. So what that means is for absolutely any circle in the whole entire universe, every single circle that you've ever seen in your entire life, if you take the circumference of that circle divided by the diameter, you will always get the same number. And that number is the special number pi. And it is approximately equal to 3.14. It is a decimal number and it keeps extending forever, but we don't want to deal with all those decimal numbers. So we just say it's approximately 3.14. And you can see on your formula sheet, they do remind you of that. So they tell you here that pi is approximately 3.14. Those little wiggly equal sign, that just means approximately or about. So pi is the special number that is the circumference of a circle divided by the diameter. Very smart people figured that out a couple thousand years ago, that we have this cool number pi to help us out with measuring circles. So let's talk about our formulas here. The formula for area of a circle is pi times the radius squared. So when we're calculating area, we need to use the radius. And the formula for circumference, you can actually see they give us two different versions of the formula here. The basic version of it is that the circumference is pi times the diameter. But if you know the radius, you could think of it as 2 times pi times the radius. And that's because the diameter is just twice as big as the radius, right? So it's up to you which version you want to use. Usually I just kind of remember this version here, and I know that it's easy to kind of convert between diameter and radius. All right, so let's get some practice with these formulas. With this blue circle here, we know that the radius is 6 inches. Now we're going to fill in the rest of this information. So if the radius is 6 inches, then the diameter is 12 inches. And the circumference, we want to think back to our formula. Our formula is pi times the diameter. So that's going to be 3.14 times the diameter, which is, I'm going to get out my calculator here. 3.14 times 12 gives me 37.68 inches. And I'm not going to round that at all because I don't have any instructions telling me to round. But if you had a problem where it did give you instructions on what place to round to, you want to make sure you follow those directions. All right, and then the area is pi times the radius squared. So I'm going to do 3.14 times 6 inches squared. Now you want to make sure you're following the order of operations here. So you would do your exponent first, right? 6 inches squared is 36 square inches. And then you multiply that by 3.14. And altogether that gives me 113.04 square inches. All right, now let's look at our second circle here. We know our diameter is 10 feet. And that means that the radius is 5 feet. The formula for circumference is pi d. So we're going to do 3.14 times 10 feet, which is 31.4 feet. Formula for area is pi r squared. So 3.14 times 5 feet squared. Get out my calculator here. And that is 78.5 square feet. Make sure you are also doing these calculations along with me. Make sure you are getting the same answers that I am when you do your calculations. All right, so now, you guessed it, we're going to flip things around. So if you know the area or circumference, how do you use that information to find the missing radius or diameter? So let's start with this first circle here. We know the circumference and we are trying to solve for the radius. So this is a problem involving circumference. I'm going to start with my formula. And I'm going to start with the simplest version of the formula. Even though it doesn't use the radius, I know that once I figure out the diameter, it'll be easy for me to figure out the radius. So I'm going to use C equals pi d. I'm going to fill in the information I know. So C is 21.98. Pi is 3.14. So now this is an equation that we can solve for d. And to solve it, we're going to divide. 21.98 divided by 3.14. And we get a diameter of 7. And if I double check my units here, that's 7 miles. Now we're not done with the problem, right? Because we didn't want the diameter, we wanted the radius. So if the diameter is 7, the radius is going to be half as long as that, so 3.5 miles. All right, now in the next circle here, we know the area, we want to solve for the diameter. So again, I'm going to start with my formula. Area is pi times the radius squared. And this formula uses the radius, but I know once I know the radius, it's easy for me to get the diameter. So fill in the information you know. And now this is an equation that we can solve for r. So working to get that r by itself, I would divide by 3.14. So r squared equals 314 divided by 3.14. And that's going to be r squared equals 100. So now we want a number times itself that's equal to 100. In other words, we want to know what is the square root of 100, and that's 10. So here the radius is 10 centimeters, and that means that the diameter is 20 centimeters. All right, and we're going to finish off our lesson here with a couple of practice problems. So number 1, a total of 48 feet of fence is required to enclose a square vegetable garden. What is the area of the garden? So I'd highly recommend that you go ahead and pause the video here, try and solve this problem yourself, and then come back to it when you think you've got it. All right, so we've got a total of 48 feet of fence is required to enclose a square vegetable garden. So this is the amount of fencing going all the way around the square. That means that 48 feet is the perimeter. And the question asked me about the area. What is the area of the garden? So I'm going to think about if I want to calculate the area of a square, what is the information I need to know? Well, the information I need to know is the side length, right? I need to know how long is one side of my square. So I'm going to use my 48 feet to figure that out. I've got 48 feet all the way around. If I divide that by my 4 equal sides, that tells me it's 12 feet per side. So now I can calculate my area. I get 12 feet squared, which is 144 square feet. So this vegetable garden has a perimeter of 48 feet, and it has an area of 144 square feet. Number 2, Eva has enough mulch to cover 100 square feet of a garden. She wants to make a rectangular garden that is 25 feet long. What should be the width of her garden? So I know the length of this rectangle. I'm trying to figure out the width. And what about this 100 square feet? What number is that? What measurement is that? Is it perimeter? Is it area? Is it length? Is it width? What does that number mean? Well, one clue I have is that this number is given in square units. So right away, that should tell me that this is the area of the garden. You might also get that from this keyword here, which is that we're talking about covering the garden, right? We want to remember that area is the amount of space inside of the shape. It's the amount of space that's covered by the shape. So this problem tells us the area. Since we're talking about area of a rectangle, I'm going to start with my formula. And then I'm going to fill in the information I know. The area is 100 and the length is 25. We want to know what the width is. So to solve for W, we would divide. 100 square feet divided by 25 feet will give us 4 feet. So this garden is going to have a width of 4 feet. All right, on to the next one. Number 3, a theme park has a circumference of 37.68 kilometers. What is the radius of the theme park? So we're told about circumference, so I'm going to start with that formula. Fill in the information I know. And now I need to solve it for the missing piece. So I'm going to divide 37.68 divided by 3.14. Get my calculator out here. And that equals 12. So I have a diameter of 12 kilometers. Am I done answering this question? No, I am not, because, right, the question is actually asking about the radius. So my diameter is 12. That means that the radius is 6 kilometers. So this is a pretty big theme park that we're talking about here, right? That's about a 5-mile radius that we're talking about. All right, well, thank you all so much for joining me on this lesson. Make sure you watch this all the way through and take some notes before you try your homework. And if you do have any questions, please get in touch with me. I hope you're all doing well, and I will talk to you all soon. Take care.